Good morning all. In this video we will be discussing about a unit hydrograph. The concept of unit hydrograph was first given by L.K. Sharman in 1932. Then a definition of unit hydrograph. It is defined as a hydrograph of direct runoff resulting from one unit depth, that is 1 centimeter of rainfall excess occurring uniformly over the basin at a uniform rate for a specified duration d hours. That is, we will study word by word. That is, it is defined as a hydrograph of direct runoff. So it is a hydrograph of direct runoff, that is we are removing the base flow and it is resulting from 1 unit depth of rainfall excess. Okay, that is this direct runoff is due to 1 unit depth of rainfall excess. So the total direct runoff it is 1 centimeter occurring uniformly over the basin, okay, and uniform at a uniform rate for a specified duration. Then specified duration, that is d hours. What is specified duration? That is, it is a duration of rainfall where the rainfall excess is there. Okay, that is not, it is not represent the complete duration of the rainfall. It represents the duration of rainfall having a rainfall excess. That is, there is a runoff. The rainfall excess represent the runoff values. Then a unit hydrograph is designated according to its unit duration. See, the rainfall excess occurs for in 3 hours, then that is called unit hydrograph of 3 hours. So this represents the hydrograph of an area. Okay, consider this is a hydrograph of the catchment. So in this case, the duration of rainfall is 6 hours, but the rainfall excess, as you can see, above this line represent the rainfall excess. The rainfall excess here it is 3 hours. So that 3 hours represents the specified duration or unit, we can call it as unit duration, not the entire time period for the rainfall. Then we know the area under the hydrograph represents the total runoff. We have already studied what is a hydrograph. The area under the hydrograph represents the total runoff. The hydrograph represents the base flow, sub-base flow, subsurface flow and surface flow. So area under the hydrograph represents the total runoff. So area under unit hydrograph represent the direct runoff. That is, we are removing the base flow, and direct runoff of what is the quantity? What is the amount? It is 1 centimeter. Then next one, one of the property of this one, if two identical storms occur over a drainage basin with identical condition prior to the rain, the hydrograph runoff from the two storms would be expected to be same. That is, if you consider the same drainage basin and having identical rain, then the hydrograph will be same. Then from this basic premise implies that the rainfall excess of n centimeters resulting from a storm of certain unit duration will give a runoff hydrograph having ordinates n times the ordinates of unit hydrograph of the same unit duration. I will explain this with a figure. That is, consider this represents the red line represents the direct runoff of a drainage basin, and this blue line represents the unit hydrograph. Okay, and consider the rainfall excess, that is the runoff, it is n centimeter if you consider direct runoff hydrograph, and if you consider unit hydrograph, the rainfall excess will be 1 centimeter. Okay, then if you consider the ordinate of unit hydrograph, say it is 1, and the ordinate of direct runoff will be, here the rainfall excess is n, so it will be n into y. This is what is explained over here. Okay, the rainfall excess of n centimeters resulting from a storm of certain unit duration will give a run of hydrograph having ordinates n times the ordinates of unit hydrograph of same unit duration. That is, unit duration is same, that is 3-hour duration. Maybe the hydrograph which we have drawn is 3-hour duration, and the unit hydrograph is also for 3-hour duration. So the ordinate of direct hydrograph is equal to n times the ordinates of the unit hydrograph. Then assumptions of unit hydrograph theory. First assumption, the effective rainfall, that represents the excess rainfall. Excess rainfall indicates the surface runoff is uniformly distributed within its duration or specified period of time. That is, the effective rainfall it is uniformly distributed within its duration. This is the first assumption. Second assumption, this effective rainfall is uniformly distributed over the entire area of the drainage basin. This is the second assumption. Then third assumption, for a given drainage basin, the base period of hydrograph of direct runoff corresponding to effective rainfall of different intensities but same unit duration is constant. So first we will look into base period. What is base period? Say this represents the base period. That is the time from which the runoff, that is discharge, increases in the stream and it reaches to the normal value. That represents the base period. So yeah, you consider two different intensity rainfall. Okay, two different intensity rainfall, and this represents the losses. Okay, this represents the losses, and if you consider effective rainfall or rainfall excess, here it is 36 mm, here it is 56 mm. Okay, so the rainfall intensities are different, but the rainfall excess duration of rainfall excess is 3 hours. Here also it is 3 hours. So here same unit duration, but intensities are different. Then the base period of hydrograph is constant. If you consider, if you draw the hydrograph, hydrograph due to this rainfall, okay, you will get a hydrograph like this. Similarly, if you draw the hydrograph due to this rainfall, you will get this one. So from that, the base period, it is constant. It is approximately constant. We are take it as constant. This is the assumption. Okay. So here, what is the duration of excess rainfall is constant, is same for both the rainfall, but intensities are different. Even though the intensities are different, the base period of the hydrograph remains constant because it is having the same duration of excess rainfall. This is the third assumption. Then fourth one, the ordinate of all direct runoff hydrograph of a common base period are directly proportional to the total amount of direct runoff represented by each hydrograph. That is, if you consider the ordinates of this one, second one, if you consider the ordinates, say this represent O1. Okay, that is proportional to the total direct runoff. That is, it is proportional to total direct runoff. Similarly, if you consider this ordinate O2, it is proportional to this direct runoff, or will get like this. If there is a common ratio, that is O1 by O2, you will get it as the direct runoff of this hydrograph divided by direct runoff of this one. So the ordinates are directly proportional to the direct runoff. Okay, ordinates are directly proportional to the direct runoff of the hydrograph. Then last one, for a given drainage basin, the hydrograph of direct runoff corresponding to a given period of rainfall reflects all physical characteristics of the basin. That is, if we got a hydrograph of a given drainage basin, that represents all the physical characteristics of the basin. Next is derivation of unit hydrograph. How to derive a unit hydrograph from a hydrograph? Okay, select a hydrograph resulting from an isolated, intense, short duration rainfall of nearly uniform distribution over the entire basin as well as within its duration. So we have to consider isolated and intense short duration rainfall. Then measure that is we have to measure the discharge in the river. So then draw the hydrograph. Then what is the next step? We have to separate the base flow. So then these are the different steps. I will explain with this figure. Say consider during the rainfall I have measured the discharge in a river. So these are the discharge data. This is the time. Based on this one, this is the obtained hydrograph. Okay, this is the obtained hydrograph. And next step, we have to remove the base flow, because a unit hydrograph means it's a hydrograph of direct runoff. So first step, we have to remove the base flow. So I am removing the base flow. Okay, we have studied different methods to remove the base flow. Using one of the methods, I have removed the base flow. So finally, if I remove this much area, okay, this area, finally you are getting this much area. Okay, so this graph represents only the direct runoff. Next one, we are going to calculate direct runoff volume. For that one, we need each ordinates. Say this represents the ordinates O1, O2, etc. O10. It depends upon the time duration. Okay. Then next one, we are going to find out what is the direct runoff depth. So first we are going to calculate direct runoff volume. How to calculate volume? Here the discharge in cumex, that is in meter cube per second, and the time duration in hours. So discharge into time, you will get the volume of direct runoff. So sigma O represent the sum of ordinates into T is the time interval. Okay, time interval, that is 5 to 8, it means it is 3 hours. So time interval is 3 hours, converting 3 hours into seconds, because this is in meter cube per second. So meter cube per second into hour, so convert hour into second, that is 3600. The next step, we got the volume. Next step, we have to find out the direct runoff depth. How to find out the direct runoff depth? That is, we know the area of the basin. Say this represent the entire area of the basin. Okay, we have to divide this volume divided by area. Here area is in kilometer square. Okay, area is in kilometer square. So converting kilometer square into meter square, so into 10 raised to 6. So here we are getting in meter. This much value we are getting in meter. Okay, then here it is, this is in meter cube, sorry, this we are getting in meter square. So finally you will get in meter, converting that meter into centimeter, so into 100. So we will get in direct runoff depth in centimeter. So divide this each ordinate using this direct runoff depth, you will get the ordinate of unit hydrograph. So O1 divided by this direct runoff depth, O2 divided by direct runoff depth, you will get the ordinates of unit hydrograph. This is the direct runoff hydrograph. Then we are dividing each ordinate using direct runoff depth. You will get the ordinates of unit hydrograph. This represents the ordinates. This is how we are deriving the unit hydrograph. Hope it is clear.